We have three waves all moving in the same direction to the right, and they all have the same frequency, lambda and amplitude, and that they kind of have different phase shift angles. And we know that if we add them all up, the amplitude of the resultant wave is going to be 2.2 times the amplitude of the original waves. Let's try to express this as the sum of the y's is going to be equal to, let's say the first one is going to be amplitude times, we'll call it a sine wave, and then we'll have a kx minus omega t, and we don't have any angle for that one. The next one, however, will have the angle, so let's add that in. And then the third one will just be with a double angle, kind of, so like this. Now that's pretty long, so let's go ahead and kind of replace this whole thing with just a theta. And so it'll kind of just be a sine of theta plus a sine of theta plus this phase thing, and then kind of like this with another theta, but here's a two phase. From here, the hint was to add these two together, so let's try to do that. And if we were to do that, then we would come up with some sort of an expression like 2a cosine of, well, something over 2. It's not really going to be just a phase angle here, because usually it would be just a phase angle here. But remember that the angle is actually this that we're adding together. So like, you know, if that was just the angle, it would be 2 theta, 2 angle. So we'll put that right in there. And then, because that would be our angle. And then we can figure out that it would be a sine, and then we'll just sort of leave this as the theta. And then we're going to sort of do that little trick again, because this would sort of technically just be 1 theta there, but our angle was actually the 2, so we need a double angle there. So that kind of nice. These things will cancel. And then that's one of these, but we need the other wave as well. So let's go and add that in before we move on. Okay, cool. So if we try to rewrite this a little bit, we'll notice that it's going to be like 2a cosine of the angle, and then a sine of the theta plus an angle. And then now we have another a sine of theta plus this angle. Let's go and factor out an a sine of this term. So kind of like a sine of this term here. And then let's see if we can figure out what would be on the left over here. A sine of this stuff, and then it would be plus 1 over here, right? Let's just turn into a 1. So we could say 2 cosine of a phase plus 1. Now at this point, we could realize that this whole thing right here is supposed to be the amplitude of this new sine wave at the end. So let's just set that equal to what they were giving us, 2.2a. 2.2a. This stuff over here doesn't matter too much. And now we can see that the a's will cancel. So if we were to try to solve this, we would subtract 1 from both sides. We'll get 1.2. That will be equal to 2 cosine of the angle. Let's divide that by 2 and take the arc cosine. So that should give us our angle. Let's just go and do that on the calculator real quick. And we'll see the arc cosine of 1.2 over 2 gives us the radian of 927.927 there. Interesting.